Hello, this is the first part of the 2008 Oxford PAT. So 2 hours, they've dumped the whole lot in together. Previous papers, they put them in separate bits of an hour each, but no difference really. We got no calculators throughout this year though. G still 10 meters per second squared, which is just as well if we don't have calculators. So yeah, I'm going to start off. This will just look at part A, which seems to be the maths question. So that's what, 12 questions. So that's what I'll do in this video and then put the rest in subsequent videos. So we're starting here with evaluate the sum of these integers. So we're adding up all integers 1 to 100. So we want to do the usual thing of pairing them up. So all of these pairs add up to 101, and then we have to multiply them by half the number of numbers that are in it because they're all in pairs. So we're going to have 101 times 50, which is 50/50. So that's a nice start for that one. Evaluate these two things. So we've got a quarter to the minus a half. So that is 1 over the square root of a quarter. So square root of a quarter is a half. 1 over a half is 2. We've got 2 there. That was 50/50 on that one. And then 0.09 to the 3 over 2. So let's square root it first to get 0.3 and then cube it to get 0.027. So that's just a bit of basic mental maths there. Question 3. The first three terms of the series expansion of this are that. Find the first three terms in the series expansion. Oh, right, okay, this is going to be a bit of a mess, probably. So, right, they've given us, right, we have to change these things, right? So the first change in here to here is we've gone from m to m plus 1. So we just need to reproduce this with an m plus 1 where everywhere that there's an m. So let's put this up here. So we're going to have 1 plus m plus 1x plus m plus 1, then m plus 1 minus 1, so that's m over 2 times x squared. So we don't need to obviously do any more than that because we're only looking at three terms when we multiply them together. The thing that's changed in this one is our x has gone to minus 2x. So we need to change those things around. So we're going to have 1 minus 2mx, because we're replacing the x with minus 2x. Then we're going to have, that'll end up being a plus, wouldn't it? So we'll have 4x squared, so 4 divided by 2, so 2 m minus 1 x squared. So we've now got to multiply these together for the for going up to powers of x squared. Right, so let's do these in bits then. So we do our x to the 0 term is just going to be 1 because we're going to have the 1 times 1. Our x to the power 1 term, well, we can only get those by having, well, it's going to be that times 1. So we've got m plus 1 times x, and then that times 1, so minus 2mx. Now our x squared term is going to have a lot more bits in it. So we can get the two original x squared terms because they can both be multiplied by 1, but then we've got these two multiplied together is going to give another one. So, oh, I shouldn't have written the x's in. Well, okay, I could leave the x's in there. I was going to write them as coefficients, but it doesn't really matter, does it? So yeah, we'll leave that in, leave that x there. So for this one, we're going to have m plus 1 times m over 2 x squared plus 2m m minus 1 x squared, and then what have we got? Minus 2m m plus 1 x squared. So what are we trying to do with all this? We just need to simplify that down, don't we? That's all we've really got on all of this. So all in all, we've got 1. I might have gone off the edge of the screen. I'll move it in a bit. 1. Where are we? So this is mx minus 2mx plus an x. So that's going to leave us with 1 minus m. So plus 1 minus mx Then we've got on this one, okay, let's put the x squared down at the end with some bracket of stuff. What have we got on all of these then? So we've got, oh, there's so much stuff in all of this. Right, I'm gonna have to write all of these out, aren't I? Right, well, let's deal with these bottom two. So we've got, oh, 2m squared minus 2m squared. So that's good. So they're just going to disappear. And then we've got so that's minus 4m that we've picked up out of those bottom two, minus 4mx squared. And then, so that's dealt with those. And then for this top one here, we've got a m squared over 2 and a plus m over 2. So we've got minus 3.5 m's in all of this. So that gives us minus, oh, they're both going to be over 2. So that's our minus 3.5 m. And then we've got, what was the other one, m squared over 2. So yeah, obviously you can lay that out a lot more neatly when you're actually on a sheet of paper, but you'll see the chain that's going through on all of that. Right, that was quite a long question compared to the others, considering it's only given us one more mark than the previous one. Seems a bit harsh, or maybe generous on that one. So where are we now? Question 4. Find the set of values of x for which that inequality holds. Right, so we've either got, so if because we need to be careful if we multiply by a negative number as to what happens with the inequality. So we'll take 1 minus x squared to be greater than 0, so that's great. So we're saying really there that mod x is less than 1. If that's the case, then we can just multiply through. That's going to be fine. So we're going to get x squared plus 2 has got to be less than 3 minus 3x squared. So what's that? 4x squared has to be less than 1. So that means that x is going to, well, mod x has got to be less than a half for that one. So that's fine because it doesn't clash with our condition that we've got there. So that's one set of values that we've got. And then if we were going to do it again and say if 1 minus x squared is so negative in this case, then what we're saying with that is that mod x is greater than 1. Then what we're going to get is we're going to have to turn the inequality sign around. So we'll have x squared plus 2 has to be greater than 3 minus 3x squared. So we'd have that 4x squared has got to be greater than 1, in which case x has got to be, well, we've got that mod x has got to be greater than a half, but that's then clashing with that. So yeah, we've got these two options then. So we have to stick with mod x is greater than 1. So they're our two options that we've got. So if you're going to draw that out on, you know, on a number line with 0, then we'd have to mark on the half and the 1 minus a half minus 1. Then we're fine if we're here or there, but we're not if we're in these areas. Yeah, you can do that a different way as well. If you square the whole thing, then it takes out the issue of the negative number. So that could be another option of it. Square everything, then yeah, multiply through, simplify stuff. So yeah, two different ways to skin a cat. Question 5, given that x log base 9 of 2 is that, then find these things. So if that is the case, then from our log definition, 9 to the x equals 2. So if we do, what we're trying to get here, base 2 now we need on this. So let's do log base 2 on both sides. So log base 2, well, x log base 2 of 9 will be equal to 1. So in this case, we're just going to get 1 over x. We can do exactly the same with the other one. So we can do, yeah, we can do the same thing. So let's just move over to the side here. So we do, what we got, log base 8 this time. So x log base 8 of 9 is equal to log base 8 of 2. But yeah, 9 of course is 3 squared, so yeah, we can change that and say x log base 8 3, take the 2 down, is equal to, so log base 8 of 2 is going to be a third, so we're going to end up with log base 8 of 3 is going to be 1 over 6x. So yeah, you're just playing around. As soon as they have all the same powers in here, you've got 3s and 9s, 2s and 8s, and it's all going to be, as it always is with logs, it's all about those powers. So yeah, you just have to shuffle those around a little bit. Question 6, find the two values of x for which 1, x squared, and x are successive terms of an arithmetic progression. I'm just going to flip colour because it's getting a bit cluttered on the screen. I'm losing track of where I am. So we're saying a equals 1, a plus d is x squared, and a plus 2d is equal to x. So we've got that 1 plus d is x squared, just subbing the first one into the second one, and that 1 plus 2d is equal to x. So we can now equate these d's essentially. So we can say x squared minus 1 is equal to x minus 1 over 2. We just need to solve this as a quadratic. What have we got on all of that? We've got 2x squared minus x minus 1 equals 0. So that's going to factorize quite nicely, isn't it? 2x, it'll be plus 1, wouldn't it? And then x minus 1 is equal to 0. So we've got x is equal to minus a half or 1. Nice. 7. Determine the value of a such as the curve y equals x plus x squared over 2 plus x cubed over 3. Okay, this sort of infinite series we've got going on here, and the line y equals ax have the same gradient for x equals 0. Right, well, we know that the gradient of this graph is that. So we've got a gradient a there, so we want the gradient of this thing over here to be a as well. So let's get our y dash, which is going to be 1 plus, what we're going to, x plus x squared, okay, plus x cubed, right? That's why they've done what they've done. So we've got all of that. When x is 0, that gradient is going to be 1, so we're going to need, so y dash equals 1 when x equals 0, so a equals 1 as well. Okay, so that's fine. When x is equal to a quarter, when x is equal to a quarter, then y dash, that's now a geometric series, isn't it, going up in quarter each time. So we need a over 1 minus r, which is going to be 1 over 1 minus a quarter, which is 4 over 3. So that's a in inverted commas here. That's a different a. So a is in the first term of the geometric series. So yeah, we need a to be that then. So in this second case, we need a to be equal to 4 over 3. Right. The points 5, 2 and minus 3, 8 are at opposite ends of the diameter of a circle. Determine the equation of the circle. Right, the midpoint of that line, so is going to be at 1, 5. Just averaging those numbers for x and y. The radius is going to be, oh, so it's a 3, 4, 5. So we've got a radius of 25, 5 even. So yeah, right, I was jumping ahead to right in the equation for the circle there. So all we have to do is stick everything in and say x minus 1 squared plus y minus 5 squared equals 25. Yeah, so that's pretty straightforward. Yeah, sometimes with those, if you've got that and you write out the 5, 2 to minus 3, 8, so you know you've got a line that's looking like that, and then draw on those sides. You know, you can do some similar triangles off of it for the center, so we know that that has got a distance of 8 in it. and that's got a distance in 6 in it. So you can see then if you take a small one, you've got a 3 and a 4, so that must be a 5, and it tells you where the middle is. So sometimes it helps to draw out a picture, but after a while you end up doing so many of these questions that you don't really need to do that anymore. Let's scroll down. Question 9, and it's nice to have a bit more space as well. A die is biased, so the numbers 5 and 6 are obtained 3 times as often as 2, 3, and 4. Number 1 is never obtained. Calculate the probability that a 2 is thrown. Right, so we've got 3 chances there, 3 chances there, 1, 1, and 1 there. So we've got 9 different outcomes in all of this. So a 2 must be 1 over 9. 2 consecutive throws give a total of greater than or equal to 10. So we've got, so yeah, what can we do for that? We've got a, well, we could go 5, 6. Well, actually, we're doing 5 or 6 twice. That's one option. Or we've got to do a 4 and a 6, or a 6 and a 4. So they're going to be the same on those. So if we were going to do 5 and a 6, so they've both got a chance of 1 in 3, so that'd be 2/3 multiplied by 2/3, because 2/3 of the time we're going to get a 5 or a 6. And then we've got 2 lots of 1 over 9 times 1 over 3. So that's going to give us 4/9. Well, we're going to want everything over 27 at the end of this, aren't we? So 12 over 27 plus 2 over 27 is 14 over 27. So the dice ones always end up being relatively straightforward, I think, on these. So scroll down again, and this time question 10. So we've got a cube has side A, find the length of its body diagonal. I've got a bit more space up here. Yeah, I have. So if we've got a cube, let's just see, let's visualize what we're doing here for a diagonal. Draw all of that in, that's our cube. So change color. So we want to go from here to here would be a diagonal. So if we draw that in, that means we've got that side and that diagonal with a right angle there. These are all side A, so we've got A there. This is going to be, this side here is going to be the square root of 2a squared. So we've got, well, we'd be squaring those again, wouldn't we? So yeah, let's put it into another Pythagoras. 2a squared plus a squared. So we've got a root 3. Cool. So that one's fine. Evaluate 2 integrals. Right, these ones are always nice because you don't have to do much with these. This is going to be, so what we've got, x squared over 2 plus x to the 4 over 4 plus x to the 6 over 6 plus x to the 8 over 8 from -1 to 1. So that's just going to cancel out because we're going to put the 1 in and get a whole load of values. The -1 will become positive for all of these, but of course we have to take it all off. So we just got this symmetrical function going on there, so that comes out quickly as 0. That is going to be x to the 10 over 110 plus x to the 100 over 1100 from 0 to 1. So the 0 bit isn't going to make any difference. So we're going to have, well, let's put it all over a common denominator. 10 over 1100 plus 1 over 1100, which is 11 over 1100, which is 1 over 100. Right, that is nice. Right, this is the last one, and they're finishing off with the geometry one. So in the figure below, the shaded area ADEC is defined by concentric circles which share a common centre at O. Right, I'm going to have to scroll down and sort of lose it. All right, okay, A, C, D, yeah, okay, right. So these are circles, and they've chopped off this bit here. Then they've put in a shaded triangle ABC, straight lines AD and CE, if extended, pass through O. Okay, right. So what do we know about the triangle? So AD, AB, BC, CA and CE are all the same length. So every straight line is the same length. So this is an equilateral triangle that we've got in the middle then. I said these extend into the center. So if that is an equilateral triangle, it means that we've then lost a third of the circles. So we're trying to get the ratio of the two shaded areas. Wow, okay, so the ratio of the two shaded areas. So we've got the area of the big circle minus the area of the little circle multiplied by 2/3 because we've lost all this bit around here. Yep, that seems right. To the area of the triangle. Right, so let's let the radius of, which way do I want to go? Do I want to, let's take the smaller one. I'm wondering whether to give this length here a value and say that's x, or whether I'm going to take the radius of the small circle, I think, and call it r. So the radius of the small circle I'm going to say is r. So that means that the so what have we got then? So the area of the small circle is just going to be pi r squared. So we're happy with that. The area of the triangle is going to be, so half the base times the height. So the yeah, we said that is r. So the height is going to be 3/2r. So we've got 3/2r, that's our height, and then we need to multiply by half the base, which is going to be r sine 60. R sine 60 degrees. So we've gone through this before, you know, with these equilateral triangles. When you get these, then we know that the center of it is 1/3 of the way up, because we've got all of these triangles, all these right angle triangles. They're all 60 degrees right angles. So it ends up that of course will have to be, this length here has to be half of that length there when you do the trig on it. I've gone through this on loads of videos. So that's how that drops out a lot quicker. So this is equal to, well, sine 60 is √3/2. So we've got 3√3 over 4 times r squared. Right, so that's done two of the shapes. Now we need the big circle. So the area of the large circle, that is going to be, so we need the radius of it. Now the radius is, so we're going from here, we know we've got r, and then we need the length of AD. So the length of AD, oh, is twice of that r sine 60 thing, isn't it? So yes, it is. So yeah, that's fine. So we need to, so yeah, let's write all this out. Radius of large circle is equal to, so we've got r takes us from O to A plus AD. AD, so that's the same as AB, which is equal to 2 times r sine 60 degrees, because that's what we worked out from here. Okay, so that is √3r, r√3. So we've got r plus r√3, so that's good. Right, so we've now got to do pi r squared on that. So pi times r squared 1 plus √3 all squared. Okay, so that's good. Do I want to do anything with that? I mean, maybe I want to, yeah, let's get rid of the square and say, so that's going to be 4 plus 2√3 on all of that, isn't it? So 2 pi r squared 2 plus √3. Excellent. Right, so now we just need to tidy all of this up into some kind of ratio. So let's change color again so we don't lose track of where we are. So we have to do 2/3 of the 2 pi r squared 2 plus √3 minus pi r squared to 3√3 over 4 r squared. So all the r squareds are going to disappear. Boom, boom, boom. Let's put it all equal to 1 on the other side. So we've got 8 over 9 root 3. 8 over 9 root 3. Oh, and we've got a pi that we can take out. And that's going to be 4 plus 2 root 3 minus 1 in all of that. So all in all, if I can just squeeze this on, there must be something I can. Well, that's got a 3 and a root 3. Yeah, so there lots of things are going to cancel there, aren't they? Well, maybe not lots of things. Some things. Let's go over this side. 8 pi over 9 root 3 multiplied by 3 plus 2 root 3 to 1. So we can cancel that root 3 with that root 3 and one of those root 3s. So we're left with 8 pi over 9 times root 3 plus 2 to 1. So yeah, that ended up being quite fiddly. The key part, as is usually the case though with these geometry ones, is getting that basic equation, our shape equation of what it is we're actually trying to work out. Because not only does that help guide you towards the answer, it gives you a pattern of working. It makes it a lot easier then for the person who's marking it to follow what you're doing. Okay, they might struggle to follow what's left on the page here because I'm not setting it out top to bottom as you would do on a sheet of paper. But if you've laid it out this way and said, right, this is what we're trying to achieve, here's each one of my areas. Now we'll put it into this formula, maybe with a little aside like we've done here in order to work out the radius of the big circle, or this little aside in order to work out the relationship between the radius of the little circle and the height of the triangle. So you're trying to keep a constant flow as the main body of your work, which is all of this stuff, maybe with the odd little asides that we've got in these things. So, but yeah, I really like these geometry questions. They're satisfying to work through. So that completes that section. The rest of this paper is on physics, so I'll split that over the next 2 videos.